Hi everyone, good evening. I'm super happy to be here to present to you today about the great microservices migration that took place at Uber. So what will you get from this talk? So what I'm going to walk you through is very briefly how we went about running this migration. And I'm going to explain one way to do it, which you can then reuse. And then I'm going to talk about what it took to scale this microservices architecture. So I am Charles. I'm an engineering manager at Uber. I work on the payments team in Amsterdam. And I'm actually super happy to be in Nantes because it's actually the city I was born and raised in. So I joined Uber in July 2012. And when I joined, Uber was a pretty small startup. And I was very lucky to see the growth and to see Uber grow from from 10 cities to 600 today, and from 20 engineers to more than 2,000 today. And when I joined in 2012, Uber had a very simple architecture with one dispatch engine that we would use to keep track of the position of rider and drivers, and the API, what we would call the API, which is pretty much all the rest. So that was the business logic, the payment, the sign-up, all of this good stuff. And this API written in Python was using PostgreSQL as a database. And today we'll be focusing on API because this code base grew quite a lot, reaching about 450,000 lines of code. And the migration took place between mid-2012 when I joined, and it finished a couple months ago. So it's a very recent thing. And during this period, Uber grew from 2 services to 1,000 services. So when we give this number, which is approximately 1 service for every 2 engineers, it seems quite large. And yes, it is indeed quite large, and we probably have too many. But one thing that people might not be aware of is that there's a lot of complexity behind the scene, especially on the driver side. And so that might explain why there are so much complexity. So just a few words about microservices. I'm sure a lot of you are familiar with this term, but it's interesting to see the trend the industry went through, starting with the spaghetti-oriented architecture with copy and paste. And then into the year 2000s, that's when we start seeing a monolith with a well-structured layers, usually model view controller, MVC. And then in 2010, that's when we see the microservices start, where you have small services that interact with each other. And one thing to know is that when we started this migration, it was the beginning of this trend. And so there were a lot of things to figure out. And so it was really a 5-year adventure. That's what it is in the end. And we had to learn a lot of things. And I want to share with you some of this learning and how we went about learning. So this talk is not exhaustive. It's 20 minutes, so I need to go fast. And I will focus on a few things. And it is also, I don't consider myself an expert. I think there's still a lot of things to learn for everyone in this field. So first, I would like to spend a bit of time speaking about why we split the monolith. The first reason is a large monolith slows down developer. The tests are slow, the deploys are slow, it takes a long time to refactor. For onboarding new engineers, it takes a lot of time as well. And so that's one reason. And that indeed might explain why, if you look at the number of commits per day, they have actually not increased that much, even though there were a lot more engineers at Uber. The second reason is a monolith app usually suffers from the tragedy of the commons. Nobody really owns it. Nobody owns the core libraries. And so it's very difficult, for instance, when there's an outage, to find who is the responsible team. And you lose a lot of time, a lot of precious time. And then the last one, the most technical one, which is a monolith is very difficult to scale. Usually it uses a single database, so you have to take care of that. And also, usually it's a single point of failure. When it goes down, everything goes down. And indeed, we had quite a few difficulties scaling API in 2015. So we were running out of PostgreSQL MasterDB connection. We were running out of memory and machines. And probably the most unexpected thing that we didn't see coming is we were launching all those new cities in all those countries. So we were adding a lot of translations. And those translations, at some point, ended up using 1 GB of RAM. And this is one of the efforts that we did to kind of lower that. So now that I've explained why we went about this, I'm going to start about how do you start this microservices architecture, and then how do you scale it. So the first step is to make a rough plan, a very rough one, to at least know where you're going. Because you really don't want to move from one monolith to a distributed monolith, where basically you would have none of the advantages of microservices and all the inconvenience. And it's also useful for one thing. I am not sure if you've heard about Conway's law, but this law explains that basically a piece of code will ultimately reflect the organization that builds it. So for instance, if you have 8 teams building a compiler, usually the compiler will have 8 passes. At Uber, we had a rider team and a driver team. Each of those teams built a rider payment stack and a driver payment stack. And now we're trying to merge them. So the reason you also want to plan is then you can design the architecture, and then you can design the teams around this architecture instead of the other way around. One caveat, though, it is very easy to overplan. A lot of time when we plan some engineering feature or some engineering architecture, we plan it as if we were launching a rocket ship, even though we make a lot of assumptions in the beginning that are wrong, and then we see they are wrong only at the very end. So that's why you have to be very careful also about not overplanning. Still, before starting, 3 prerequisites that are very important. I actually recommend having those stuff even if you don't plan to have a microservices architecture. The first one is business monitoring. So the nice thing with business monitoring is when you monitor your business, you know that something is broken if there's a degradation in the metrics. So for instance, if CPU utilization goes up from, I don't know, 80% to 90%, it might not mean that anything is wrong. But if you're expecting 40 signups per day on iOS every day, and for 2 days you have 0, you probably broke something. So you probably want alerting on those business metrics. The second thing is feature flags. So here you basically have a way to deploy a change to this value, to the use new flow probability value, very quickly without deploying code. And this way you can increase the probability that you will use a new flow as opposed to the old flow without a deploy. And that lets you very quickly make change to production and very quickly roll back if anything goes wrong. And then the third thing is an abstract storage layer. So usually it's quite easy to do that in a model view controller pattern, but you still want to be careful that really before taking on a microservices architecture, all the logic that is specific about storage is in one place, and we'll see why a bit later. So the first step then is to build a ROB bridge. So what I mean by a ROB bridge is you will start with one microservice and one use case. And you will basically, taking the example of a customer service, you will basically build this customer service, build the database, maybe do one test of like a sign up just to make sure that everything's working. And the goal of that is to make sure that you have everything you need. And you will not deal with any edge case, you will really focus on one simple ROB bridge. The second thing is you have to migrate the data and keep it up to date. So there's 2 ways to do it. Usually you will do both of them. The first way is you migrate the data in batch. So you do it one time. You will migrate all the data. And then the second thing is you use shadow writes to continuously keep the data up to date. So in the repository layer in the monolith, you will write both to the monolith and to the new service. And this way you will make sure that ultimately the 2 databases are in sync. In practice, it's a lot more complicated, but that's a rough idea here. So then when we are here, we have the data migrated, and we have the data kept up to date. So we have 2 data stores in sync. So what we want to do now is that we want to migrate the reads. We have just migrated the writes, so now we want to migrate the reads, because we don't want to touch the client, and we don't want to touch the customers. And so for that, you will use shadowing reads. So the idea here is in the monolith, you first get the user from the database. You then get the user in the new service. You will compare them and make sure they match. If they don't, you will probably log a critical error somewhere and have some kind of alerting on it. But then in the end, you will still return the safe user. This way, you're sure you didn't break anything. And then when you feel ready, what you can do is reverse shadowing reads. So this is where you can use the feature flag. And so basically, you still get the boss users. You still verify them. And then in 1% of the case, 10%, 100% of the case, you will return the new user instead. And what this gives you is this will require from you productionization. So one thing we actually did at Uber when we did one of those first migration is we had rolled out the new service 100%, but in the monolith, the tests were still using the storage layer, the database layer. So we had to kind of rush and rewrite so that we would use some kind of mock for the new service. Distributed transaction, sometimes you will have to deal with like, okay, what if the write read fails in the new service but succeeds in the monolith? And then data analytics. That's also something very easy to forget. But if you have one database and you have users who do analytical queries on this database, and now the data is in another place, then you will have to find a solution so that they can still query those two databases, or maybe you have a warehouse. So after step 3, what you have is the data is in the new service. You have the reads and the writes going to the new service. So this is when you can basically delete this old data. So the next step is we're going to start migrating the consumers one by one. And so for this, it's also a great opportunity to redesign the interface. So usually the monolith had an interface. In the new one, maybe you want to have a different interface. So it's a great opportunity to fix some technical and some product depth. It's a great way also maybe to investigate whether you want to move to event sourcing, to better separate the offline and the online queries. Maybe you want to also make the interface microservices aware. When you've done that, you've migrated all the clients, and you can delete the old code. So it's really a bottom-up approach. You start with a rough plan, you do the rough bridge, then you start with the writes, the reads, the consumers, and you keep going for all the services. So now I would like to spend just a little bit of time on scaling this microservices architecture. So sometimes people assume that by moving to this monolith to a microservices architecture, it's going to be much simpler. But actually, the complexity moves from being in the code base to being in the integration. And there's a lot of complexity there, a lot of decision to make, from RPC, from debugging, how do you trace the log, how do you trace performance, from security, how do you do service-to-service authentication. So there are a lot of topics, and I will only talk about testing. So at Uber, we have many testing strategies. Staging and end-to-end tests, we tend to not use that much because they're pretty costly and very indeterministic. We do testing on production, but there are some issues with that, and that's why we found a really winning combination, which is tenancies. Usually when you test on production, you need to know the side effects. So for instance, if you're testing like the trip flow in Uber, you know that your credit card will be charged, and you might not want that. It is also very difficult to share with other teams because they don't know those side effects. And so there's a better way to do that, which is tenancies. So the idea behind tenancies is that you have some kind of metadata on the object. You can store it on one column in your database or a different table. And then when the object is in this test tenancy, you can have a different behavior. And so in this case, when we try to charge a trip, if the trip is in the test tenancy, we will mimic the external call. This is a very crude example. We'll sleep for 500 milliseconds, and then we'll return, and we will not charge a call. And then you have all the benefits of testing on production. So there's no extra cost to having when you have a staging environment. You can give this method of testing to other teams, and they don't need to ping you. They can just do their testing. The only drawbacks is obviously it's not suitable when you actually want to test the side effects. So this is just one example of learning that we had as an organization. Oops. And so very briefly, I would like to talk about how do you foster learning and how do you speed up learning. The first thing is we tend to oppose in a microservices organization speed and versus quality, even though they go hand in hand. So one very important thing is for each team to have objectives in terms of engineering metrics, but also and product metrics, not either one of those. The second one is like in a microservices architecture, it is much more important to be resilient than to be smart. There will always be something that goes wrong. There will always be a services that goes down. Everything needs to be gracefully degrade the experience to make sure that you can be resilient to those outages. The one way to promote learning is by standardizing. There's always a lot of analysis paralysis because there's a lot of decisions you can make. So if you standardize, for instance, if you say, we're going to only support Go and Java as an organization, then you can speed up this learning because you're not blocked on those decisions. And it also creates a virtuous circle because you've standardized the programming language. Now you can also standardize the libraries, for instance, if you want to standardize how we do RPC. At Uber, we also have this RFC, request for comment process, where teams need to say, hey, this is how I'm planning to design this new service, and this gives an opportunity for people to provide feedback and say, hey, have you thought about using this existing tool or this off-the-shelf component? And the last thing is you really need to schedule time for learning. My favorite is chaos testing. So this is when you intentionally break things on production to see how the system behaves. Obviously, you need to make sure that there's no user impact. Blameless incident reviews. So those are times during which you will review an incident and you will not look at the individual mistakes, but you will look at the context. Having an external and an internal blog. And also having this informal brown bag lunch and learn where anybody can come and teach something and anybody can learn. So as a summary, for Uber, scaling the microservices architecture really meant building this learning organization where we keep iterating and we keep learning. Because new services tend to become monoliths, and so you have to keep iterating and this never ends. Thank you very much. Feedback is welcome on my email, and the slide will be on my blog in a couple minutes. Do we have time for a question? Any question? Yes. Ouais. Qu'est-ce qui a décidé de se lancer dans la migration? En fait, c'est quoi le facteur déclenchant de dire maintenant on y va dans cette migration? So the question was, what was the main factor behind the migration? Well, we're seeing like a huge slowdown in the developer productivity because this 400,000 line of code was really difficult for new engineers to comprehend, very risky as well. So for instance, because we had all those commits, we would do back-to-back deploys. So we would say, OK, 20 commits will be deployed now, and the deploy would take 4 hours, during which nothing else would happen, and then 20 more commits would go. And for each of those deploys, one thing that would happen as well is one of them would break API, so we would have to roll back, remove the commit, and redeploy again. And so the main thing, I think, the main problem behind the monolith is that it really slows down teams. I'm sure there's ways to make sure you keep this speed, but at least that's what we see. That's what we saw at Uber. Any other question? Nope. Oh, here? Sorry. But you don't have a mic, right? Just yell. Bonjour.
Je le fais en français.
Pas de problème.
Bon, ça allait un peu vite, alors je ne sais pas si je n'ai pas tout suivi ou si tu ne l'as pas dit. Mais à un moment, tu avais un schéma avec tous les microservices qui s'interconnectent, qui montre que c'était plus difficile que le monolithe. Tout à l'heure, il y avait une conf sur Kong, comme une API Gateway. Est-ce que Uber, vous essayez d'utiliser des trucs genre API Gateway pour vous aider à connecter tout ça entre eux?
So the question was about, this one. So basically, the question was about, OK, there's a lot of complexity that goes into interconnecting all those services, and some companies use API gateways to kind of streamline that. So we do have, and simplified a bit, we do have an API gateway between the devices and the backend services. So we do have that, but still, within the company, there are still many services that need to talk with each other. And it doesn't, I mean, some companies have experimented with it, but I'm not sure I would recommend having one main API gateway because it would become a single point of failure. And so if anything happens to this API gateway internally, if every single call has to go through it, then it's a single point of failure. You also lose a bit the benefits of a microservices architecture. I think a better pattern to decouple this is actually event sourcing, where instead of doing RPC queries, you just send a message to an event bus, and then you have services reacting to those messages. And this is much more powerful. Oh, maybe one last? Yeah.
C'est sur la standardisation qui a amené plus de vitesse à Uber, a priori. Mais est-ce que le principe des microservices, c'est pas au contraire de séparer, de donner plus de responsabilité aux différentes équipes? Est-ce que c'est pas un petit peu antinomique?
That's a very good question. So the question is about, OK, standardization goes against microservices because the whole notion of microservices is that each team should be empowered to do whatever it wants. That is very true. It is definitely contradicting, but in practice, what happens is for an organization, if you don't standardize, you will have problems such as, okay, I'm a new engineer, I would like to join this team, but they're working in Go, and this other one is working in Haskell, and this other one is working on this other language, and then it actually slows down, and you kind of lose the benefit. So there's this. The other thing is standardization lets you provide a very high bar for quality. So for instance, if you standardize like code coverage tools, then you can mandate like 80% code coverage for every single team, and you can keep a very high bar in terms of quality. So there's a point where like if each team creates services in their own language with their own technology, it's very difficult to operationalize and not very cost effective for the company. Okay, I think we don't have time for other questions, but if you want, you can drop me an email. I'd be very happy to chat with you. Thank you very much.